Okay, my good friends, they are looking for cures for everything. Obviously, there's a ton of disease, and they're trying to find cures, and they're talking about this 30-year mystery behind Holy Grail of cancer drugs, which is Taxol. They're claiming is the big thing. Now, we're going to look into Taxol because I don't see it quite that way myself, but again, this is just research. I'm not recommending anything. I'm not unrecommending anything. I'm just looking into what their claims are and see if we can see anything that we can, match it up to, or is there validity there, or what is somebody else saying? Because you can't just take one side. If you take one side, you are being led. You understand what I'm saying? You have to look and think, and then look and think, and then look over there and think. And then you make it all together and you say, well, this is what makes sense. So let's see what makes sense. Okay, so they're saying this Taxol, a very important drug, and they just couldn't really make it easily, so it was very, very expensive. And now they finally have decoded the biosynthetic. Bio means life. Synthetic means it's not really, they're nibbling away at the bits and pieces of it to make it a synthetic product, not a natural product. Now they call it Taxol. It's a crucial chemotherapy drug solving a decades-long mystery. Well, they couldn't figure out how to make it, basically. They had to make it from some tree. A Danish research team cracked the full biosynthetic synthesis of Taxol, enabling cheaper, eco-friendly production in yeast. What they did was they took some kind of yeast and then they clipped into it and they inserted these things that create enzymes, some little program in there that creates enzymes. It says it's good for all these different types of cancers. Well, I looked into that, and I want to discuss that a little deeper. It says making this life-saving medicine has been anything but simple. Current production method, costly, complicated, places a heavy burden on an environment because it relies on intricate chemical semi-synthesis. They're not really synthesizing it, they're sort of screwing around with the molecule. Now, for more than 30 years, around the world have been chasing a big question. How does Taxol, a natural compound from Pacific yew tree, form in nature? They want to make it. Cracking this mystery could open the door to producing Taxol through biotechnology, offering faster, greener, and more affordable solution. Now, here's what they say. Now, researchers at the University of Copenhagen have discovered the two, listen to this now carefully, the two missing enzymes. They discovered the two missing enzymes that complete the final steps of Taxol's biosynthesis, how it's all being half-life subtracted down to a product. They found these enzymes, and I'll show you what enzymes do, and they are elegant. So now they can make this. These enzymes, that's the key, enzymes, are the key to making Taxol. They're the key to everything, making anything. Almost nothing is made without enzymes. It's just amazing. So they're making this into a big deal. Well, I'm going to show you what I discovered about Taxol. Okay, I think it's a little bit deceptive what they're talking about this Taxol. So I put in, is Taxol, I don't even want to say that because they don't like talking about these kind of things on YouTube. And I'm not talking about it, I'm just showing the research. I asked if it was a cure. The reason I'm asking this is because they made it sound like we finally got a cure for everything. We've had a breakthrough. Well, they're saying that it's effective for many patients, but it's not a universal cure. Its success depends on factors like what type of this disease you have, the stage, the patient, the response. It sounds like it's hit or miss. Now listen to the side effects. Hair loss, fatigue, nausea and vomiting, loss of appetite, diarrhea, mouth sores, low blood cell counts, neurothrombotic, whatever that is, low white blood cell, anemia, thrombocytopenia. It comes with a lot of things. In the nervous system, it's got numbness, tingling, pain. I'm not saying everybody gets this. It can worsen with cumulative doses. Shortness of breath, low blood pressure, skin rashes, flushing. I don't see a big, gigantic breakthrough here. Nerve damage, liver toxicity, change in menstrual cycles. Myalgia neither often occurs 2 to 3 days after treatment, lasts a few days. These are the side effects which are very, very telling in my mind, because they're messing with your bacteria. Your bacteria create the enzymes. You do not have that bacteria working for you when you have diarrhea, when you have constipation, when you have nausea, vomiting, gas, bloating, abdominal distress is poor digestion. So what happens? You don't get your enzymes. You don't get your food broken down. You don't get your energy. You get weak and all this. I mean, I just went through the whole thing. All of these things: pain and stiffness in your joints, slow heart rate, hair loss, nausea, vomiting, diarrhea, everything you can think of. Now, is that a great breakthrough? I'm not so sure. Now, most of you know I study the digestive system, and you only digest because your bacteria is there to create enzymes. If you don't have the enzymes, you will die in 2 to 4 minutes. That's just a fact. Enzymes create chemistry 24 hours a day, 7 days a week. And if you don't have those enzymes to break down the foods and all the other things you need to break down, the fats and carbohydrates and all those things, and to attack invaders, you'll be sick. You're just going to be sick. Now, there's something called a fecal matter transplant, which is the bacteria that's in a person's gut. And if you replace that with some very healthy bacterial matter inside your gut that is deficient, it will take up residence, start growing there, and create all the drugs your body needs. That's what they're there for. But you have to have the bacteria replaced. Sometimes you have to remove all the bacteria in your body almost, because it's overgrown in places, and you just can't fight back against it. So you got to wipe it out first, and then repopulate with the good bacteria, and it's a very effective. Now, it says it's not a cure-all. Powerful targeted treatment for a few diseases and a research tool for many others. The future may be promising, but it's not ready to replace mainstream therapy for most conditions. Let me know if you want. Well, it is ready to be used, at least tried. And this is right now. They won't even let you try it here in the United States. You see this? You saw all the side effects of those other things. This is FMT, conditions other than C. diff. Now, C. difficile, they'll only let you have that if you fail regular drugs. They want you to take drugs before they'll let you have the natural cure. All right, so, and here's what it says up here. It says the United States, FMT, primarily approved for the Food and Drug Administration for treatment of recurrent. That means you can't get rid of it with the drugs. Clostridium, which we have not responded to standard antibiotics. The antibiotics, anyway, the approval includes FDA approved products like Ribota and Vumps, which are designed to restore a healthy balance to the gut bacteria by introducing fecal microbiota. Well, this is pretty much gone by the wayside, because they can't create this IND. There was, I forget what the name of it was, but if you look it up, the state of fecal matter transplant, they gave up on it. They're trying to produce it and put it out there in good quality, clean stuff, so no problems. And the Food and Drug Administration made it so hard, they finally just gave up. And the big thing about it, it works, it does everything we said it does, but we just couldn't handle the paperwork. That's what they said. And you can't have it. It's only approved under certain specific circumstances. It's investigational, but they're not investigating. Clinical trials may access FMD such as inflammatory bowel disease, irritable bowel. All of that stuff is because you don't have the bacteria. This ain't intestinal. You got to have an application for this. That's why they finally gave up. It's impossible to note that it's important to note that the FDA has issued warnings about the potential risks. Well, if it's just you use it from anybody, from anywhere, maybe you can get infected, yes. But it doesn't appear to be really bad, as far as I could determine. If you look up the cases of issues, it doesn't have a whole lot. And they say it can serious infections caused by multi-drug resistant organisms related to the investigational use of FMT. What they did was they put the fecal matter from people that were infected with diseases that they thought responded well, and they put those into other people, so they transferred that disease into that person. That's what they're talking about. Caused by multi-drug resistant organisms related to the investigational use of FMT. They took some bacteria from a person that they thought responded to treatment, and they said, "Ooh, they got good bacteria in their gut." So they took that and put it in other people. What they did, they transferred the bad bacteria. So they infected other people. They just didn't know what they're doing. And this is a consideration: clinical oversight, regulatory approval, safety, efficacy. Well, let's just look a little deeper. Here it is right here. Fecal matter transplant is generally considered safe only when done under strict medical supervision with carefully screened donors and in approved clinical settings. Well, they want to throw a little medical lingo in there, but it's just FMT is most established safest for treating recurrent Class C diff. Why don't they give it to them in the first case? The success rate is 80 to 90% after they're almost dead. A low rate of serious side infections. No side infections at all, basically. What I mean, you're going to have a little stomach distress because you're going through a little repopulation and so forth. Maybe nothing. But they won't let you have it. All right, let's see what it is good for and what it isn't good for. FMT is the restoring of the gut microbiota. A study suggests it may improve the efficacy of immune checkpoint inhibitors, helping in the cancer and other cancer therapies, especially in cases where patients have developed resistance to conventional treatments. Okay, listen to this now. This is where FMT comes in, especially in cases where patients have developed resistance to conventional treatments. Then they give them the FMT, and it improves the efficacy of immune checkpoint inhibitors, and it helps. All right, here's a more detailed look at FMT's potential in cancer treatment. They have to get the gut working correctly. If you have gut distress, you're going to not be healthy. It's just as simple as that. If your gut is not digesting correctly, you're not going to be healthy. Even if your gut is digesting almost correctly and you're still missing some bacteria, some specific enzymes, you can be deathly ill just by missing a few enzymes. Just a few will make you ill if they're the wrong ones. And this is all restoring the microbiota, modulating the gut, enhancing immune efficacy. It's doing all those things. Potential benefits: improved immunotherapy response, overcoming resistance, enhanced anti-tumor effects, treating side effects, ongoing research, clinical trials, phase 1 and 2 trials, melanoma and other cancers, future directions. Now they're saying, so safety concerns. Well, they say there's almost no problems that I found. Individual variability. Well, some people's guts aren't going to work the same as others, and by the time they put it into them, they've had them on so many antibiotics that it's hard to come back. They need future research. Of course we do. In conclusion, FMT holds promise, a potential tool enhancing cancer treatment, particularly in combination with immunotherapy. See, at least they can keep their dope moving. Ongoing research and clinical trials are exploring its effectiveness in various cancers and exploring more targeted approaches to modulate the gut microbiome for improved cancer outcomes. The articles on this in the National Health Institute go back to 2001, I think, that they were really, really looking into this. And just, there's no money in it. That's the problem. These are natural bacteria. You can't patent those. What they want to do is take a bacteria and twist a couple of little particles in there so that it's not really the correct bacteria. Then they say, now we can produce it and make a whole batch of money on it. But you're going to have a bunch of side effects. Now, if you took the real one, which you're supposed to have in your stomach anyway, it appears that you might be better off. And I can't say one way or the other. I am not making any. I'm looking for the research. And you have to make a conclusion when you see this, and then you see that, and you see this is very good over here, and this one's very bad over here. Well, make your own decision. But fecal matter transplant is a natural thing. They should call it digestive bacteria replacement, because once you isolate all these different bacteria, you can grow them in a vat. You don't have to take them out of somebody's body, but you need a database to know which ones are good and which ones are bad. And then you can supplement them, and we could have a whole batch of health going on. This is National Institute of Health. FMT increasingly being used to treat various diseases, literally everything. All right, here's a patient who was getting the fecal matter transplant for C. diff, has shown promising results in improving cognitive function in some individuals with dementia, including those with Alzheimer's, because you're missing the sheathing of your nervous system. Studies and case reports suggest FMT may reduce AB plaques and tau pathology, improve cognitive impairment, and delay cognitive decline. That's a fecal matter transplant. Here's right here. Research suggests a link between gut microbiome and Parkinson's disease, which is another neurodegenerative disease because of the myelin sheathing is getting worn up. And they say it's gut-brain axis. They always knew that it was there, they just didn't know how it works. And it works by creating these bacteria, creating these enzymes. The enzymes are breaking down the stuff so quick that it can be used to do biology. If you don't have the enzymes, you're done. And you need a good, strong population of the good bacteria to keep the bad bacteria at bay. And you're going to have bad bacteria. There is no stopping it. No stopping it. Your good bacteria has to do that job for you, and you have to have it in sufficient quantity to do the job. Not a big thing to understand. There it is right here. Potential treatment for allergic diseases, particularly food allergies. It's the FMT is the transplant. We all know about that. Here's a FMT. Shown promising results in some cases of alopecia, a condition causing hair loss. While not a definitive treatment, FMT is linked to hair regrowth in patients with this AA, particularly when combined with other medical conditions like Crohn's disease or Clostridium difficile infections. Those are the things that kill your hair. You fix your gut and your hair comes back. They had one guy who had something universalis, which means his whole body, his hair couldn't grow. And after he had a fecal matter transplant for C. diff, everything came back. His hair started growing the whole 9 yards. I think he was like 80 years old. This is just insanity, but they won't let you have it. Okay, I think if you look at the evidence, they should at least be able to do a little more research on this. It's not being researched the way it should. Every time you look at any one of those different things, they say, more research, more research, more research. Well, let's do it and let's get it done. But they didn't. They want to step away from it. The Open Biome wanted to produce this stuff and distribute it. As Open Biome has stated publicly, the discontinuation of FMT distribution is not related to the safety or quality of the products, but rather the difficulties the organization has had in making its submission to the FDA. Over the past 22 months, they made it so complicated, they finally gave up. They said, "Ah, to hell with you people, we're just going to close up." And they did. This is not right. This is just not right. It should, at least should be investigated much more rigorously than is happening now, and for many, many, many years. Now this goes way, way, way back. This is around the year 2000. They were treating cholesterol, the CDI, using, and also irritable bowel syndrome, inflammatory bowel, other conditions in the gut. And while the NIH did not have a dedicated large-scale initiative, no, not at all, like the Human Microbiome Project until later fiscal year 2007, that's still almost 20 years ago. The growing awareness of this CDI and the anecdotal success of FMT likely contributed to the growing interest in microbiome research 20 years ago. All right, which ultimately led to larger initiatives supporting NIH funding. Larger initiatives supporting funding in subsequent years. Well, they never got anywhere, and it's still illegal. You know, like I say, I see things and I have to point them out. I'm not saying do this, don't do that, but I think the government should take a good look at this, and I think Robert Kennedy Jr. should contact me, because I have a lot of research on this. All of this stuff, enzymes and bacteria live in the fluid-filled highway primarily, and they pass all around the body carrying all these products and enzymes, ribosomes, which do the chemistry. If you get hit by a pulse of magnetic radiation, like from a nuclear blast, it kills all the bacteria in your body, and then you get acute radiation sickness. A couple hours later, you start throwing up, you lose your bowels, you have diarrhea, you start throwing up. Because you destroyed the bacteria in your body, can't create the enzymes anymore. And that's how fast they work. Within a couple of hours, your body can be destroyed because you killed your enzymes created by your bacteria.